Hey there, everybody. Welcome back. We are now working on section 5.7 in College Algebra. This is Math 44. 5.7 is on literal equations. And this is a fairly straightforward topic. In literal equations, a literal equation has two or more variables. Where we solve for one of the variables. Another word you might know these as is formula. Formulas. Or formulae. Formulae might be, let's look at that. Maybe you learn something every day. Formulae, what is that? E. Formulae is a plural form. So formulas or formulae. That's for me being an avid reader. I like to read a lot. So formulas. Also known as formulae. Fun fact. We've seen them. You've looked at them. We've just used them in different ways. This should look familiar. That's the perimeter of a rectangle. Area of a rectangle has more than two variables in it. So you've seen a bunch of these before. All right. So the goal with literal equations is isolate a specific variable. We usually want it solved for one of them because that's the answer that we want. And when we have it solved that way, you can actually, that's where you start using computers and stuff and make it a little bit easier. So let's just take a look at some examples. If it helps you visualize the other variables as numbers and how you would solve that way. Let's go with our perimeter. Let's start with that one. Perimeter equals 2L plus 2W. Let's solve for L. So when I say solve for L, I want to get L by itself. I want to say L equals what? So if we had something like 3 equals 2L plus 4, this is fairly straightforward. We subtract the 4 over and we divide by 2. Well, now instead of having 3 and 4, we have P and W, but that process doesn't change. We're gonna, just like here, we subtracted the 4. That was what was added to 2L. We're gonna subtract 2W from both sides. And just like we did with L, we will divide by 2. And I can say L equals P minus 2W over 2. Or I could treat this as 1/2 P minus 2W. Or I could say L equals 1/2 P minus W by distributing. Not too bad. Just got to treat the other letters like numbers and solve like you would. All right. Why don't you guys give it a try real quick? We in the past have given the circumference of a circle. C equals 2 pi r. Solve for r. All right, I will assume you did it. 2 pi is right now multiplied by c, so we will divide both sides by 2 pi, and we get r equals c over 2 pi. This is about as straightforward as a lecture we can get. You treat the others like numbers. All right, let's kick it up a notch. We are going to solve for B1. The formula will be A equals 1/2 B1 plus B2 times H. And this is the area of a trapezoid. Okay, or yeah, trapezoid. All right, so A equals 1/2. I'm going to put the H with the 1/2 and write this as H over 2. Or you probably won't do that, so let's go back and put it as 1/2 and the H after. So what we can do is if we multiply both sides by 2, it gets rid of the fraction. So now I've got 2a equals b1 plus b2 times h. Then I can divide both sides by h. And I get 2a over h equals b1 plus b2. We finish it off by subtracting b2 from both sides. And I get b1 equals 2a over h minus b1, or b2. All right, let's do another one. In the following, we're going to solve for y. 1 over x minus 1 over y equals 1 over z. All right, so the way we did it before when we had a bunch of fractions, these were rational expressions, we found the LCD, which should be 1 from each denominator, x, y, z, and we're going to multiply both sides by x, y, z. So here I've got x, y, z over x minus x, y, z over y equals x, y, z over z. And when we simplify that, we get yz minus xz equals xy. This is kind of like having 5y minus 12 equals 3y. Like here I've got z is 5 and x is 3. Maybe if I put this as 15, that would make more sense for what I just said. Similar idea. What we would do here is we would get the y's together and we would get the 15 to the other side. Then we divide by 2. So that's what I'm going to do. I'm going to get the y's together by subtracting this over. And I'm going to add xz to the other side. Just like I did over here. And now what I have is, and I'm going to put the y as the second letter. zy minus xy equals xz. Now, I can't combine them like I did here. 5y minus 3y, I was able to combine them, but I don't know what z and x are. So I can't do that. But I bet if you stop and think about it, you might be able to figure out what we can do. Pause the video, see if you can figure it out. If you said, let's factor out a y, pull the y out. You're right. Good job. Because that's how we could do 5y minus 3y. I could write that as 5 minus 3 times y. Here, I'm able to combine them into 2y, but over here, I can't. But the idea is still the same. I would divide by 2 here. Well, now I'm going to divide by z minus x. And I get y equals xz over z minus x. Look at that. Isn't that beautiful? Let's give you one to try that's something like this. The following formula is for resistors in parallel in electrical engineering or electricity in general. When you have resistors in parallel, this is the total resistance. Total resistance R for two resistors in parallel, R equals 1 over R1 plus 1 over R2. Let's solve for R2. All right, so same method, clear the fractions. We can see the LCD is R1, R2. And I will write the R2 last. So I've got R, R1, R2 equals, I distribute here, the R1 cancels, I'm just left with R2. And I distribute here, the R2 cancels, and I'm just left with R1. And I'm looking for that boy, that bad boy. That's what I want to use. So I'm going to subtract, well, darn it, I already said it. I'm going to tell you to work this out. I think I already did. So we've got R, R1, R2 minus R2 equals R1. And here I can factor out the R2. I have R1 minus, if I pull this out, I got to have something in there. That's just a 1. And so if I solve for R2, I divide both sides by R1 minus 1. And I get R2 equals R1 over R1 minus 1. Bam. That's all there is to this topic. All right. Peace. Oops.